Hey everyone, welcome back to the channel. Let's solve the problem subarray divisibility. In this problem, we are given with the array of n integers and our task is to count the number of subarrays where the sum of values is divisible by n. So for example, if n is 5 and we have this array, then the output should be 2. How is this the case? One subarray I can say is 2 plus 6 plus 2 divided by 5 is going to give remainder 0. That means it is divisible by 5. And the second subarray I can say is 2 plus 1 plus 2 is 5. That is again divisible by 5. So the output is 0 and that is the second subarray. So we print total 2 subarrays. Now let's try to analyze this portion, how this portion is contributing to our subarray. 2 plus 1 plus 2 is 5, right? So let's see array, and this is going to follow the same pattern which you have seen earlier, and this in the subarray subarrays 2, I guess, the previous to this problem. And so if we have, let's say this is sum 1 and it is going to leave remainder r, these two blocks contribute to s1, that is sum 1, and leaves remainder r, and this complete array is s2, sum is sum 2 s2 and leaves remainder r. Then I can definitely say that the left out portion is going to be divisible by n, and that is the equation we can see. If someone can be written as multiple of n, sometimes n multiplied by some quotient and plus remainder r, and s2 is again the same pattern, and if we subtract them out, s2 minus s1, then the result is coming as a multiple, some multiple of n. And in this case, let's take the example. So here s1 is 8, 6 plus 2 is 8, and if we try to divide it, this s1 by 5, that is going to give us remainder 3, right? And similarly, if this s2, which is 2 plus 6 plus 2 plus 1 plus 2, is 13, and if I can write that as 5 into 2 plus 3, where 3 is the remainder. Here also the remainder is 3, here also the remainder is 3. That means the left out portion is definitely, this left out portion is definitely going to be divisible by n, and that's the whole logic which we need to see. And that's the same thing, we are storing our remainder and that prefix sum into a map. And there is one case which is made for negative numbers. Remainder can't be negative numbers, so we find the concurrent of it. So let's say if we are getting a remainder minus 3 here, minus 3, then we are simply going to add n. Let's say that n here is 5. If n is 5, so we just add here n. So minus 3 plus 5 is going to give us 2, which is not equal but congruent, and that is, there is a whole mathematics behind, you can read it. So these two pair are congruent to each other, so hence we will write 2 whenever the sum drops to 0. Let's look and the pseudocode. We are again having a map which is going to store our prefix sum count. Then we have sum and count, and again we will store 0 as 1. This is all coming from the previous video, and again we are going to loop into the array, and then we are going to calculate the sum. So sum would be sum plus n divided by not divided but modded by n. That is, we are storing our here remainder basically. Don't go into the naming convention of the variable, but here we are storing our we are calculating the remainder. Now if sum is dropping to 0, we are making sure that it is non-negative, hence we are adding its congruent by plus n, and then we have our count which is going to check in the map for the particular that remainder, how many count is there, and then we will just update that into the map, and again we are going to return the count. So here we have inputting the n and the array, and then we are calling that function which is going to give us the count. The same thing, we have our map, we do the logic here, and then we simply return. Let's try to submit this, and it has been accepted. So this problem is quite similar to the previous one, just we have to check the fact that when it is dropping to, remainder is dropping to 0, we are adding n, and here we are performing that divisible mod operation.